Hey there, scientists! Caroline here. I was just checking my local AQI, and it looks like the pollution from the local wildfire has now cleared to much safer levels. This got me thinking. It's really nice to have access to air quality information right at my fingertips. And it's also nice to know that on most days, the air outside is safe for me to breathe. This is true in most American cities. The AQI is most commonly scored as moderate or good. It's easy to take this for granted, but healthy air quality hasn't always been a reality for most cities in the US. In fact, as recently as 50 years ago, this is what Salt Lake City, Utah commonly looked like in the morning. Now it looks like this. So what changed? In today's lesson, we'll explore this question as we look into the Clean Air Act. Along the way, we'll discover how scientific data can help us identify problems and propose meaningful solutions. Ready, scientists? Let's get started. Scientists, before we dive into the Clean Air Act itself, let's take a step back in time to examine why it was necessary. Imagine it's the 1950s. Air pollution is becoming a serious problem in cities across the US, from Salt Lake City to New York City. Hazy skies, smog-filled streets, and health concerns are on the rise. How do you think residents felt about this pollution? People were concerned, raising the issue in their communities and putting pressure on lawmakers. Now imagine that you are in charge of creating laws in the 1950s and 60s to improve air quality in the US. But there's a challenge. Any new pollution laws will impact hundreds of millions of people. On one hand, you need to protect public health and the environment. On the other hand, regulations can be expensive for businesses and the government. Before passing any laws about air quality, what might you want to do as a first step? Pause and record your thoughts in your guided notes. Probably gather information about the problem, right? You would want your decisions to be based on real-world evidence. In other words, you would need scientific data. Trying to solve air pollution without scientific data would be like trying to patch a hole in a tire without knowing where the leak is. You need the right information to take effective action. So, before passing any regulations, lawmakers funded scientific research to better understand air pollution's causes and impacts. Let's see what researchers were able to find. One of the first questions lawmakers wanted scientists to answer was, how does air quality affect human health? Data on deaths related to respiratory illness provided some important insights. Take a look at this graph. As the average particulate pollution increases, what does the data say about the average annual death rate from respiratory disease? Pause and record your thoughts in your guided notes. You probably noticed a pattern. As particulate pollution goes up, the annual death rate also rises. In science, when two sets of data follow a similar trend, we call this a correlation. This doesn't prove that pollution directly caused the deaths, but it does strongly suggest a link between higher pollution levels and increased respiratory disease. Scientists use data like this to support a key claim: improving air quality improves public health. But this information alone wasn't enough. They also needed to determine what air quality standards would improve health while also being achievable. Imagine lawmakers trying to set a law to completely eliminate pollution in American cities. Sounds amazing, but would that have been realistic? Probably not. On the other hand, what might have happened if they set a standard that was too relaxed? It probably wouldn't have improved health outcomes very much. The solution had to be somewhere in the middle. Scientists noticed that cities with particulate concentration levels of less than 75 consistently provided better health outcomes to Americans. And not only that, these cities provided evidence that similar standards were possible in the rest of America as well, making 75 a reasonable goal for all of the US. These insights were groundbreaking, but they still left another important question. What laws would actually help achieve this new air quality goal? Scientists were tasked with identifying the largest sources of pollutants. That way, lawmakers could identify which changes would have the highest impact. Let's take a look at some data on pollution levels in the 60s. This data showed that some cities had much more particulate pollution than others. Based on what you know about factors that impact air quality, what do you think the cities with the most pollution had in common? Pause and record your thoughts in your guided notes. If you guessed lots of vehicles and factories, then you're spot on. Scientists at the time noticed this trend as well. Then they performed follow-up investigations that revealed a clear trend. Vehicles and factories were some of the largest contributors to particulate pollution in the US. These insights on particulate pollution were then combined with insights from many other types of air pollution, such as carbon monoxide and other harmful gases. Altogether, this helped lawmakers understand which sources of air pollution were causing the biggest problems. And with this final piece of the puzzle, lawmakers were ready to act. The primary goal of the Clean Air Act of 1970 was to protect public health by improving air quality. In order to accomplish this, the Clean Air Act focused on 3 strategies. First, it set National Ambient Air Quality Standards, or NAAQS, for common pollutants. You can think of these as AQI benchmarks that cities aim for to ensure healthy air quality. Second, the Clean Air Act needed a way to make these air quality goals a reality. To do so, it established limits on pollution from sources like power plants, industrial facilities, and vehicles. Finally, the Clean Air Act created the Environmental Protection Agency, or EPA, to enforce the law. As part of the federal government, the EPA conducts research on air quality and health impacts, updates pollution limits based on new data, and ensures compliance through inspections and penalties. Each state is required to submit a plan outlining how they enforce new regulations and improve air quality in their cities. These new regulations had a big impact on private industries. Automotive manufacturers, power plants, and factories had to adopt cleaner technologies to meet the new standards. But the Clean Air Act wasn't just a one-time fix. It established a process to continuously review and update air quality standards based on the latest scientific data. This flexibility allowed the law to change over time, adapting to new discoveries and ensuring that air quality could continue to improve. In this way, the Clean Air Act is a powerful example of how scientific data can be used to address real-world environmental challenges. And with that, we've wrapped up our lesson on the Clean Air Act. Well, sort of. Seems like something is missing, right? We've established that scientists did a ton of research on air quality and public health, and that lawmakers passed the Clean Air Act based on that research. But did it work? And what was the economic cost? Don't worry, scientists. In the PDF, you'll have the chance to explore these questions on your own as you analyze air quality and public health trends over time. Then you'll propose your own CER claim about the effectiveness of the Clean Air Act. Along the way, you'll continue to reflect on the role that scientific data plays when making environmental decisions. Good luck! And remember, the air we breathe is a resource we all share. Every choice we make can help keep it clean, so don't underestimate the impact you can have. Stay observant, keep asking questions, and I'll see you next time. Hey.